Welcome back to the deep dive. Ever wonder how psychologists unlock those secrets of human behavior?
It's fascinating stuff, Dustin.
Totally. So today we're diving into the world of psychology experiments
Uh-huh.
to find out just how they work. We've got excerpts from
A classic.
the 10th edition of Research Methods in Psychology by Shaughnessy, Zechmeister.
And Zechmeister.
Yep, all three.
It's really the go-to for understanding these experiments. Get ready for some serious insights.
Okay, so let's unpack this. First things first. Why are experiments such a big deal in psychology? Why do we even do them?
Well, they're essential for a couple of big reasons.
Okay.
Think of it like this. Psychologists are kind of like detectives of the mind.
Okay, yeah.
They're always trying to solve these mysteries of why we do the things we do.
Mm-hmm.
And experiments help them test their theories, right, in a controlled environment to see if their hunches hold up.
So it's like putting those theories through their paces,
Exactly.
like a mental obstacle course for those theories.
Yeah, like a mental obstacle course, totally.
Yeah, I like that.
They make predictions based on their theories,
Right.
and then they design these experiments to see if those predictions actually play out in real life.
Uh-huh.
The second reason is all about problem solving, especially in those applied fields, like medicine or education.
So not just understanding why people do things,
Right.
but actually figuring out how to help them, maybe.
You got it.
Okay.
Let's say there's a new therapy for anxiety.
Mm-hmm.
An experiment could help determine if it actually works better than the existing treatments out there.
Right.
Or a new teaching method, right?
Mm.
Does it really boost student learning? Experiments provide that evidence.
Makes sense. So experiments are like the ultimate test, but how do they actually work? Like, what's the secret sauce? What's the formula?
At the heart of it all,
Yeah.
it's cause and effect. Experiments are all about figuring out if changing one thing directly leads to a change in another.
Okay, so far so good.
Yeah.
But how do we know for sure that one thing caused the other? Couldn't it be a coincidence?
That's where the real detective work comes in.
Okay.
Researchers focus on three core elements to really establish that cause and effect. First is covariation. Let's take that Barbie study as an example. Researchers wanted to know if exposing young girls to images of Barbie dolls would affect their body image.
Okay.
Covariation means we need to see if there's a relationship between the two.
Mm.
Did seeing those Barbie images actually lead to a measurable change in the girl's body image?
So if there was no change, we couldn't really say those Barbie images were the culprit.
Exactly. There wouldn't be that connection. The second element is time order.
Okay.
This one might seem obvious, but it's super crucial. The cause has to happen before the effect.
Right. So just because I eat ice cream on a hot day
Right.
doesn't mean my ice cream cone caused the heat wave.
Exactly. Precisely.
Okay.
And finally, we need to eliminate those alternative explanations. And that's often the trickiest part.
Meaning making sure there isn't some other sneaky factor at play, like some other variable that we didn't account for that's actually, doing the work.
You got it.
Okay.
So, think back to the Barbie study. Researchers had to make sure that nothing else besides those images could be affecting the girl's body image.
Right.
They had to rule out other possibilities.
Yeah, I get it.
So, maybe the girl saw something on TV that day or had a conversation with their friends, right, that influenced how they were feeling.
Right.
Researchers have to control for all of that.
Okay. So that's the logic, right? We've got the logic.
Yeah.
But how do researchers actually design an experiment to make this all happen in real life? How do you control all those factors?
Well, one of the most common approaches is the random groups design.
Oh, okay.
Okay. Imagine we're testing a new study technique to see if it improves test scores.
Okay.
We'd start with a group of participants and randomly divide them into two groups. Like, imagine flipping a coin for each person.
Right.
Heads, you're in group A, tails, you're group B.
So that's what random assignment is. Okay. Why is that so important?
Well, think of it like shuffling a deck of cards. You want to make sure each group gets a fair mix.
Okay.
Random assignment helps ensure that any pre-existing differences between the participants are evenly distributed across those two groups.
I see. So it's not like all the super studious people end up in one group and the procrastinators in the other.
Exactly.
Okay.
We want those groups to be as similar as possible at the start so we can isolate the impact of that new study technique.
Okay. Yeah.
So one group, the control group, they would study the old-fashioned way.
Okay.
And the other group, the experimental group, they get to try that new technique.
Right.
But everything else stays the same for both groups.
Okay.
Same amount of study time, same test, everything.
Okay. I'm getting the hang of this. So by controlling everything else and just changing that one thing,
Yeah.
the study technique, that's how we can see if it really makes a
Right.
difference.
You're isolating the effect of that variable.
Okay, got it. But what about those sneaky alternative explanations you mentioned earlier?
Oh, yeah.
How do researchers keep those from, messing things up?
That's where careful planning and experimental design come in. One way is by holding conditions constant. Like, remember the Barbie study? Everything was the same for all the girls except for the types of images they saw.
Yeah.
Same story, same instructions, same amount of time.
Ah, so by keeping all those other things constant,
Right.
any changes in body image couldn't be blamed on those factors. Clever.
Right.
Okay.
But there's another trick researchers use too called block randomization.
Block randomization. Okay, that sounds a bit more complicated.
It sounds complicated, but it's all about keeping those groups comparable.
Okay.
Even when the experiment takes a while or involves unpredictable factors.
Okay.
Like, let's say you have different researchers collecting data.
Oh, right.
Right.
Different researchers could influence things.
Exactly.
Yeah.
It's like creating mini experiments within the bigger one.
So even if different researchers are involved or the experiment takes place, over several weeks, we can be more confident that the groups are still balanced and comparable.
You got it. It's a way to spread out any potential influence from those factors.
Yeah.
So I think you can see how researchers go to great lengths to make sure the groups are truly comparable. It's a key part of a good experiment.
Right. They've got to rule out all those other explanations.
Next.
So it's really the independent variable doing the work.
Right. Now, even with all these precautions,
Mm-hmm.
some sneaky threats to a good experiment can still creep in. And we call these threats to internal validity.
Internal validity. So that's all about making sure that the changes we see
Yeah.
are really due to the thing we're manipulating, not some other hidden variable. What kind of threats are we talking about here? Give me the rundown.
Well, sometimes you just can't avoid starting with pre-existing groups. Like if you're studying different classrooms of students, we call these intact groups.
Mm-hmm. And why is that a problem? Can't we just randomly assign those classrooms to different conditions?
Well, you can randomly assign them.
Okay.
But even with random assignment, there might be like pre-existing differences between those classrooms that you haven't accounted for.
I see.
Maybe one classroom just happens to have a better teacher.
Right.
Or more motivated students,
Yeah.
And that could totally skew your results.
So even with random assignment, starting with intact groups can be risky.
Yeah, a bit risky.
Because of those hidden differences.
Exactly.
Okay. Are there other threats looking out there?
Oh, absolutely. There are those pesky extraneous variables.
Okay.
The unexpected factors that could be affecting the outcome, even if you didn't plan for them.
Like what? Give me some examples. I want to know what to watch out for.
Think about the temperature of the room where you're conducting the experiment,
Okay.
or the time of day,
Uh-huh.
or even subtle differences in how the researchers interact with the participants.
I see. So even small things like the room being too hot or one researcher being a bit friendlier than another
Right.
could influence how people respond.
Exactly. Subtle things can make a big difference.
Yeah, that's a lot to keep track of.
It is. And then there's subject loss.
Oh.
The dreaded moment when people drop out of your study before it's finished.
That's bound to happen sometimes. Life gets in the way, right?
Sure will.
You can't always prevent that.
Yeah. But it becomes a real problem for internal validity if the dropouts are selective.
Selective.
Meaning they're dropping out for reasons that are related to the study itself.
Okay, I can see how that would be a problem.
Right.
Can you give me an example?
Yeah. Let's say you're studying the effectiveness of a new fitness program.
Okay.
And what if the people who find the program too tough are the ones dropping out?
Right.
The folks who stick it out might be the ones who are already more fit to begin with.
Right.
So you can't really tell if it's the program making the difference or just the fact that, the more dedicated, fitter people are the ones who stayed in the study.
Wow, that makes a lot of sense.
Yeah.
It's like you're comparing apples and oranges at that point.
Mm.
So how do researchers combat these sneaky threats to internal validity? Do they just cross their fingers and hope for the best?
Definitely not. They have a whole arsenal of strategies to keep those threats at bay.
Let's hear them. I'm all ears.
Right. So let's dig into those strategies.
Yeah.
Well, one way is to kind of anticipate those potential problems,
Okay.
before they even arise, and design the experiment in a way that minimizes those risks.
I like it. Plan ahead.
Right, exactly.
Mm-hmm.
Like, let's say researchers are worried about that selective subject loss, in that fitness program study.
Mm-hmm.
They might screen participants beforehand to weed out those who are less likely to stick with it.
So it's like a pre-screening.
Yeah, like a pre-screening to make sure everyone's really committed. Or they might use a pre-test to kind of identify those who are at higher risk of dropping out.
Okay.
Another strategy is offering incentives to encourage people to stay in the study.
Yeah.
Things like gift cards, maybe small prizes.
Right. That's smart. Just to keep those participants motivated and engaged.
Right. But sometimes those threats are more subtle.
Okay.
Like demand characteristics.
Demand characteristics.
These are cues that participants pick up on that kind of hint at what the study is about or what the researchers expect to find.
So it's like the participants are trying to figure out the hidden agenda, basically.
Exactly. Like they're trying to be helpful,
Right.
But they end up, maybe acting in a way that they think the researcher wants them to act. So imagine you're in a study testing the effects of violent video games on aggression.
Okay.
If you start to suspect that the researchers expect you to act more aggressively after playing that game,
right,
you might unconsciously start behaving that way, even if the game doesn't actually have that effect on you.
That's fascinating. It's like our brains are trying to be helpful,
Yeah.
but they end up messing up the results.
Exactly. So how do researchers combat that?
Yeah, how do you fight against helpful brains?
Well, one way is to be sneaky.
Okay.
Researchers might use deception to disguise the true purpose of the study.
Okay.
Or they might create a placebo control group.
Placebo control, so that's like, giving someone a sugar pill instead of the real medication.
Exactly. In this case, the placebo group might play a nonviolent video game,
Okay.
while the experimental group plays the violent one. This way, everyone's in the dark about who's getting the real treatment.
Okay.
So those expectations have less power to influence their behavior.
Clever. It's like a psychological magic trick.
Yeah, a bit of magic.
So are we finally done with those pesky threats to internal validity?
Well, almost. There's one more big one we haven't covered yet. Experimenter effects.
Experimenter effects. Don't tell me the experimenters themselves can mess things up.
Believe it or not, even the researchers' own expectations can unintentionally influence the participants.
Wow.
It's subtle, but it can have a real impact.
Yeah, that's crazy. I never realized that even the researchers' own biases could creep in and skew the results. So how do we prevent that?
The gold standard is what we call a double-blind procedure.
Double blind, does that mean everyone's wearing blindfolds during the experiment?
Not quite.
Okay.
It means that both the participants and the researchers are kept in the dark
Okay.
about who's getting the real treatment and who's getting the placebo.
Oh, so neither the participant nor the researcher knows who's in which group.
Exactly. That's the key.
That's a brilliant way to level the playing field and just reduce the influence of all those expectations.
It adds an extra layer of protection,
Right.
to make sure that the results are as objective as possible.
Okay. So this is all incredibly helpful. We've covered, why psychologists conduct experiments, the importance of internal validity,
Right.
and all those ninja-like strategies that researchers use to combat those sneaky threats.
Right.
But there's one question that's nagging at me.
All right.
Even if our results are rock solid within the experiment,
Yeah.
can we ever be absolutely certain that they'll apply to other people?
That's the million-dollar question.
In other settings, under other conditions.
And it brings us to external validity, the extent to which our findings can be generalized to the real world.
Okay, so we've seen how researchers make sure their findings are rock solid within the experiment.
Right.
But here's the big question. Do those findings apply to the real world?
Yeah.
That's where external validity comes in.
Precisely. And it's a crucial consideration, especially if we want our research to have real-world impact.
Right. What good is a finding if it only works in a carefully controlled lab setting?
Exactly.
We want to know if it applies to people out there living their lives.
Out in the wild.
Yeah, exactly. So what are some strategies that researchers use to increase the external validity of their findings? How do they make those findings more applicable?
Well, one is to think carefully about the participants. If you want to generalize your findings to the general population, you need to make sure your sample is representative.
Okay, that makes sense.
Right.
So if I'm studying memory in, older adults,
Right.
I shouldn't just be testing college students.
Exactly. You'd want to recruit a diverse group of older adults from different backgrounds with different health histories and so on. Your sample needs to reflect the population you're interested in.
It's like making sure we're not just looking at a tiny slice of the pie, but actually getting a taste of the whole thing.
Yeah, the whole pie. And sometimes researchers take the experiment out of the lab and into the real world.
Oh, I like that.
We call those field experiments.
Okay, so instead of testing memory in, like, a sterile lab setting, I might test it in a busy supermarket or a noisy park.
Exactly. This can help us understand how the phenomenon we're studying plays out in a more natural setting, with all its complexities and distractions.
And that gives us more confidence that our findings will apply to real-life situations.
Right, where there are all sorts of things going on.
Not just the carefully controlled environment of a lab.
Precisely. Now, even if we can't conduct a field experiment,
Right.
there are still ways to increase external validity within the lab.
Okay, I'm intrigued. How do we do that?
One technique is partial replication.
Okay.
This involves repeating the experiment with some variations.
Okay.
Maybe a different sample, a slightly different procedure, or a different measure of the dependent variable.
So it's like testing the robustness of our findings by seeing if they hold up under different conditions.
You got it. If we get similar results, even when we tweak things a bit,
Right.
that gives us more confidence that the underlying relationship is real and not just a fluke of that particular experiment.
That makes sense. It's like saying, okay, our finding held up in this one specific situation,
Right.
but does it still hold up if we change things up a bit?
Exactly.
And if it does, that's a good sign.
Exactly. Now, another powerful approach is what we call conceptual replication.
Conceptual replication. Intriguing. Tell me more.
It's all about testing the same underlying idea,
Okay.
but using different methods or measures.
Okay, I'm following. Give me an example.
Let's say we're studying the effect of stress on problem solving.
Okay.
In our first experiment, we might induce stress by having participants give a speech in front of an audience.
Oh, that sounds stressful.
Right. And then we'd measure their performance on, let's say, a logic puzzle.
Okay. Seems like a reasonable setup. Public speaking is definitely stressful for a lot of people.
Totally. But in a conceptual replication,
Yeah.
we might induce stress in a different way.
Mm-hmm.
Maybe by giving participants a tight deadline
Right.
for a difficult task.
Okay.
And instead of a logic puzzle, we might measure their performance on a creativity task.
So we're changing the specifics of how we're inducing the stress and measuring problem solving.
Mm-hmm.
But the core concept is the same. Does stress impair our ability to think effectively?
Precisely. If we find that stress negatively impacts performance on both the logic puzzle and the creativity task, that strengthens our confidence that there's a real relationship between stress and problem solving, regardless of how we induce the stress or measure performance.
That's really cool. So it's like saying, look, it's not just about this one specific type of stress or this one specific type of task. There's something more fundamental going on here.
Exactly. It's about looking beyond those surface details
Okay.
and focusing on the underlying principles at play.
This is making me realize that external validity isn't like a simple yes or no question, is it?
No, it's not.
It's more of a spectrum, right?
It is.
Some findings are just more readily generalizable than others.
Absolutely. And it's important to be transparent about the limitations of our research, right?
Right.
And the extent to which our findings can be applied to other contexts. We can't just assume that what we find in the lab will always translate perfectly to the real world.
Right. It's not a one-size-fits-all situation.
Right.
But by carefully considering our sample, our setting, and using techniques like partial and conceptual replication,
Right.
we can increase those chances that our findings will be meaningful and applicable beyond the confines of our study.
Exactly. It's all about maximizing the real-world relevance of our research.
I like that.
Now, we've talked a lot about those random groups designs, right?
Mm-hmm.
Where we randomly assign participants to different conditions. But what about situations where that's not possible?
That's a great question. I imagine there are times when you can't just randomly assign people to groups. What do researchers do then?
You're right. Sometimes random assignment just isn't feasible. So researchers use other designs, like the matched groups design.
Matched groups design.
Yeah.
Okay.
It comes in handy when you have a small sample size,
Uh-huh.
and you're concerned that random assignment won't be enough to create truly comparable groups.
Got it.
So imagine you're studying the effects of a new teaching method on reading comprehension,
Okay.
but you only have 10 students to work with. That's hardly enough for random assignment to work its magic and balance out any pre-existing differences between those students.
Right. With such a small sample, any differences between the kids could easily skew the results, even with random assignment.
Exactly. So instead of relying on random assignment alone,
Okay.
you carefully match the students in pairs based on some key variable that's relevant to reading comprehension. maybe their pre-existing reading scores or their IQ scores.
So you create these pairs of students who are as similar as possible on that matching variable.
Yeah, kind of like finding their academic twin.
Right. I like it. Okay, and then?
Then you randomly assign one student from each pair to the control group, which would receive the traditional teaching method, and the other student to the experimental group, which would get the new method.
So you're building in an extra layer of control?
Exactly.
By ensuring that the groups are balanced on that key variable from the start. It's like giving random assignment a little boost.
Exactly. It's a way to enhance comparability when you're dealing with small sample sizes.
That's really clever. So by matching the students beforehand and then using random assignment, we increase our confidence that any differences in reading comprehension are really due to the teaching method.
Right.
Not some pre-existing difference between the kids.
Precisely. It's a powerful technique when used appropriately. But it's important to remember that the groups are only matched on that one specific variable.
Right. There might be other differences between the students that we haven't accounted for, like their motivation level, their learning style, all sorts of things.
You got it. And that's why it's so crucial to use random assignment after matching, to try to balance out those other potential factors as much as possible.
So it's a combination of careful matching and random assignment that gives us the best chance of creating truly comparable groups.
You got it. Now, there's one more design I want to mention that often pops up in psychology research, the natural groups design.
Natural groups design? It sounds like we're venturing out of the lab and into the wild.
In a way, yes. This design is used to study pre-existing groups like people with different personality traits or people from different cultures. The key difference here is that the variable we're interested in, the independent variable, is not manipulated. It's something that already exists.
So instead of randomly assigning people to different conditions, we're selecting people who already belong to those groups.
Exactly. Let's say we're interested in the relationship between extroversion and happiness.
Okay.
We can't randomly assign people to be extroverted or introverted. Those are personality traits that are relatively stable.
Right. They're part of who people are.
They are. So how do we study that using a natural groups design?
Yeah, how do you study something like that?
We would recruit a group of extroverts and a group of introverts and then measure their happiness levels.
Yeah.
Maybe using a standardized questionnaire or some other reliable measure.
And then we'd compare the two groups and see if there's a difference in their average happiness scores.
Precisely. If we find that, extroverts, on average, report higher levels of happiness than introverts, that would support our hypothesis that extroversion is related to happiness.
But here's the catch, right?
Yes.
Just because two things are related doesn't mean one causes the other.
You're absolutely right. That's the crucial point to remember with natural groups designs. Correlation does not equal causation.
It's a classic mistake, but it's so easy to fall into that trap.
It is. It is.
So even if we find a strong relationship between extroversion and happiness, we can't say for sure that being extroverted causes people to be happier.
Right.
There could be other explanations, right?
Exactly. Maybe extroverts are more likely to engage in social activities, which in turn boosts their happiness.
Yeah.
Or maybe there's a genetic predisposition that influences both extroversion and happiness.
Right.
We simply don't know from a natural groups design.
Okay.
It can point us in the right direction, but it can't tell us the whole story.
So how much can we actually conclude from a natural groups design? What's its value if we can't make those causal claims?
That's a fair question. While we have to be cautious about inferring causality, natural groups designs can still be very informative.
Okay.
They can help us identify patterns and relationships that deserve further investigation.
Okay.
They can also help us generate hypotheses that we can then test using those more rigorous experimental methods like the random groups design we talked about earlier.
Right, so it's like a starting point for exploring those complex relationships. It gives us clues, but we need more evidence to solve the whole mystery.
You got it.
Yeah.
It allows us to observe how variables naturally cover in the real world, which can give us, valuable insights and guide future research.
It's like a piece of the puzzle.
Yeah.
But we need those other pieces to see the whole picture.
This has been a fascinating deep dive into the world of psychology experiments. We've learned about, the importance of internal and external validity, the different designs researchers use, that tricky issue of drawing causal conclusions.
Yeah.
But there's one last piece of the puzzle I want to explore.
Okay.
How do researchers actually analyze the data and decide whether their findings are meaningful?
That's a great question. And it's crucial for understanding how researchers draw those conclusions from their experiments, we'll uncover those secrets of data analysis and statistical significance when we return for the final part of our deep dive into psychology experiments.
Okay, so we're back, and we're finally ready to tackle this data analysis puzzle.
Yes.
We've covered, internal and external validity, all the different experimental designs.
Right.
But now let's get down to, the nitty-gritty.
The nuts and bolts. Yeah, how do researchers actually crunch all those numbers and determine if their findings are actually meaningful?
Well, it's all about using the right tools,
Hmm.
and knowing how to interpret those results.
Okay.
Statistical analysis, that's what helps researchers separate real effects from just, random chance. After all, there's always going to be some variability between samples.
Even with random assignment and all those careful controls,
Exactly.
people are just complex.
They are.
So how do we tell if the differences we see between those groups are actually due to our independent variable, the thing we manipulated,
Right.
or just natural variation?
Right, and that's where inferential statistics come in. They help us estimate the probability that our results are due to chance alone.
Okay, so that makes sense. We want to be confident that our findings aren't just a fluke, like it wasn't just a random, occurrence.
Exactly. One common approach is null hypothesis significance testing,
Okay.
which we touched on earlier.
Yeah.
Remember, we start by assuming that null hypothesis is true. That means assuming there's no real effect of our independent variable.
Right. So we're basically saying, let's pretend our manipulation didn't do anything. What are the odds that we'd still see these results?
Exactly. And we use these statistical tests to calculate the probability of getting our results if that null hypothesis were true.
Okay.
If that probability is really, really low, typically less than 5%, then we reject that null hypothesis.
So if the odds of getting those results just by pure chance are super slim, we can be more confident that our independent variable, the thing we changed, actually did have an effect.
Exactly. We call those results statistically significant.
Statistically significant.
Meaning they're unlikely to have happened just by chance.
But you mentioned earlier that we can never be 100% certain.
Right.
There's always a chance we might be wrong, right?
That's the nature of science. We're dealing with probabilities, not absolute truth. Statistical significance tells us how likely it is that our findings are real, but it doesn't completely eliminate the possibility of error.
That's a good reminder that science is always evolving, right?
Always evolving.
We're constantly learning and refining our understanding. Okay, so we've got statistical significance.
Yeah.
But how do we know if our findings are actually meaningful in the real world?
Right.
A tiny difference might be statistically significant.
Right.
Does it really matter?
That's a great point. Statistical significance doesn't tell us everything. We also need to consider effect size.
Effect size. Okay, so that tells us, how big the difference between groups actually is.
Exactly. It's a measure of the magnitude of the effect, regardless of sample size. So a statistically significant finding might have a tiny effect size, meaning it's not very impactful in the real world.
So, we could find that a new teaching method improves test scores.
Right.
But if that effect size is, minuscule,
Yeah.
it might not actually be worth the effort of implementing that new method.
You got it. Effect size helps us determine what we call the practical significance of our findings.
Okay, so by considering both statistical significance and effect size, we get a more complete picture of what our results really mean.
Absolutely. We want findings that are both statistically robust and practically meaningful.
Makes sense. This is all making a lot more sense now. Let's circle back to confidence intervals for a moment. I'm still a little fuzzy on how they work and what they tell us.
Sure. So think of a confidence interval as a range of values that likely contains the true population mean.
The population mean being the average score for everyone in the group we're interested in.
Right.
Not just the small sample that we tested in our experiment.
Exactly. We can never know the true population mean for sure.
Right.
But the confidence interval gives us a really good estimate.
Okay. So if we're 95% confident that the true mean falls within a certain range, that's our 95% confidence interval.
Precisely. And here's where it gets really useful. We can compare the confidence intervals of different groups in our experiment. And if those intervals don't overlap,
okay, yeah,
we have stronger evidence that those groups are truly different.
So it's like a visual way to see how much separation there is between the groups.
Right, like a visual representation of the data.
The less overlap, the more confident we can be that our independent variable had a real effect.
Exactly. Confidence intervals just provide another layer of insight when we're interpreting our results.
This is all starting to click into place. It's making me realize that data analysis isn't just about, like, crunching numbers. It's about interpretation, about making judgments based on the evidence.
You're absolutely right. Statistical tests, those are tools
Okay.
that help us make those judgments, but they don't make the decisions for us.
Right.
It's up to the researchers to weigh the evidence, to consider the context, and to draw conclusions that are both rigorous and nuanced.
So it's a blend of, like, science and art in a way.
I like that. There's definitely a creative element to interpreting that data and drawing those meaningful conclusions.
This has been an incredibly enlightening deep dive into the world of psychology experiments. We've gone from, that initial research question all the way to the final interpretation of the data.
That's quite a journey.
We've uncovered the importance of internal and external validity, explored all those different experimental designs,
Right.
and demystified that crucial role of statistical analysis.
It's been a pleasure sharing this journey with you.
Yeah.
I hope, now you have a better understanding of how psychologists actually use experiments to unravel those complexities of human behavior.
Absolutely. And I'm sure our listeners are now equipped to, like, critically evaluate research findings and ask those insightful questions about the studies they encounter.
That's what we hope for. That informs skepticism and curiosity. Those are essential for navigating that world of scientific research.
Well said. Thank you so much for joining us on this deep dive into psychology experiments.
My pleasure.
And we'll be back next week with another fascinating topic. Until then, keep those minds curious.
And keep diving deep.